Here I'm going to show a different way to factor these trinomials, especially the ones with the leading coefficient that we can't factor out. So we've done a way that we make a diamond and then we do factor by grouping. We have 4 terms eventually from that diamond, or we split the middle. This 20v becomes something v plus something v. So now there's 4 terms and we do the grouping. I just made a video that talked about or showed a visual method. Some of you are very visual learners, and when we were multiplying polynomials together, you liked to make a square and put your factors along the top and the sides, and then find the product of each of these parts, and then combine like terms. So I've posted a video that shows, well, now we're going to have this. So when we, instead of multiplying, we factor out to get these outer parts. There's a third way to do this, folks. That's what I'll show right now. It's a guess and check method. It's a method that some higher level math teachers prefer that you be able to do or try at least. It's going to involve not a lot of writing, but what you do write with a pencil, because you will be erasing, you will be just guessing and checking different scenarios, and I'll show you how that works. So our answer will likely be the product of 2 binomials. And typically in a binomial, when we multiply 2 binomials together, if it's in standard form, we have our variables out in front. So that gives us this product right here. So in other words, when I multiply these 2 things together, I don't just want v squared. This would give me v squared. I want 3v squared. So that means I need to put a 3 with one of those 2 v's. Not both, because that would give you 9v squared, just one of them. And to get this 32 right here, you get that from multiplying those 2 terms, the 2 numbers. So what we're going to do now is think about the different ways to multiply to 32. I'm going to make a list of the factors of 32, or you can look at your list of factors of 32. 1 and 32, 2 and 16, 3, 4, and 8, and I think that's it. So I could put any one of those, any set of those pairs in to produce 32, but what we're going to actually check is, how do we get 20v? And how we get that 20v in the middle is by multiplying these 2 things together and these 2 parts together. So I know it's going to be one of these 6 combinations, but which pair goes there? And by the way, now it matters if I'm choosing 1 and 32. It matters if I put the 1 here or the 32 here. Because if I put the 1 here, it's getting multiplied by v. If I put the 1 over here, it's getting multiplied by 3v. So you basically just guess and check. I'm just going to play around with this and put the 8 here and the 4 there. And by the way, that's a positive 32. So that means either both numbers are positive or both numbers are negative. Since this results in a positive 32, or a positive 20v, I'm going to realize, just like before with what we were doing Monday, factoring the easier trinomials, they both need to be positive, not both be negative. So here's how I check this. I just guess and check. I plugged in 8 and 4 in these respective spots. When I multiply here, I get 8v. When I multiply there, I get 12v. Hey, I was trying to make one not work initially. I guessed right. If I have a positive 8 and a positive 4 there, it works. And why I say that works is because 8v plus 12v is 20v. So if I were to multiply this whole thing back together, I would get this answer right here. Let's try this one over here. I think I can kind of save the space to make it work. It's probably kind of painful to watch, huh? Yeah, sorry. I don't see the grouping thing. I must have missed it. Whatever. a second. Now I'll really do it for sure. I mean it. Here we go. All right. So again, with guessing and checking, our answer is gonna be likely the product of two binomials. So this first multiplication needs to give me a 5r squared. So I can put 5r in r. The last two numbers are going to have to multiply to 6. But there's a few ways to multiply to 6. There's 1 and 6 and 2 and 3. It's a positive 6. So it's either both positives or both negatives. Because it needs to add to a negative 17r, I think that this second list is better. I think we should use the negative numbers. Now I'm just going to start checking. Now there's two sets of pairs here rather. However, there's actually 4 combinations that I can try because the order that I put in this -1 and this -6 matter now. So -1 and -6 will produce something different than -6 and -1 for this -17r, because now that's what we're checking. We've narrowed down the options that these two terms could be in our binomials here. And how we check this is see if when we multiply these two values together and these two values together, we actually get a -17r. So let's try it. Here we get a -1r. Here we get a -30r. Oops, when I combine those I get -31r. -31r. So that's not equivalent to -17r. So that was a good try, but that's not the right solution. All right, let's try -2 and -3. Here we get -2r. Here we get -15r. What does that combine to? Yes, -17r. So these two multipliers give me the -17r that I wanted. If we were to FOIL this thing completely together, this would give me the 5r squared, and this would give me the +6. So this is the solution. Just guessing and checking. I'll do a couple more with you. So now it needs to multiply to 5n squared, so 5n and n. Then to find what numbers we need to factor to, these last two numbers need to multiply to -18. So that means one of the two factors is negative. So -1 and 18, -2 and 9, -3 and 6. But switching the negative to the other number does make a difference here. So 1 and -18, 2 and -9, 3 and -6. And like the first two examples, even if I have the right combination, even if just, for example, I knew it was this pair for sure, the order that I put the 1 and the -18 in, it matters which spot I put each of those respective ones. So there's actually a lot of combinations to try here. I had a student think of this one time. Really, we're trying to add to -9n. When we think about these factors, realize that one of them is going to get multiplied by 5. So we're not just trying to add these things to -9. Multiply one of them by 5 and put the other one over here. So once we multiply one by 5 and add it to the other one, we need a -9. That helps you do it because that's really what we're doing here. We're thinking, what combination can I use here when I multiply one of them by 5 and just add it to the other one? So I'm just going to start. I realize that in the end the negative needs to be bigger by a little bit. It's a -9. That's not a ton. I'm going to try a -3 here and a +6 there. So this gives me 6n. This gives me -15n. Hey, what's 6n plus -15n? -9n. This is the right solution. Nice. And again, if we multiply the constants together, we get -18. If we multiply the green values together, we get 5n squared. So we're solid. Now this last one's a little bit goofy, or a little bit different. I've been quick to say what the first terms are going to be. Now we need to multiply two things together to get 10 and 10k squared. So we could have 10k and k, or we could have 5k and 2k. I'm not sure which one. Luckily, at the back here, we need numbers that multiply to -2. So we're looking for factors of -2. And there's not many. -1 and +2, or 1 and -2. So we can try these combinations in the top one and see if it works. And remember that order matters. So actually there's 4 combinations here. 4 combos. If it doesn't work there, try it in this bottom one. Now, in the end, if we were to make a diamond here, we're going to take these 2 options and multiply one of them by either 10 for one of them and 1 with the other one, or 5 with one of them and 2 with the other one. And then once we multiply and add, they need to equal 1. So I guess my thought here is that since it needs to add to a +1k, the numbers need to be pretty close together, if that kind of makes sense. So I'm leaning towards this one right here. This thing gets multiplied by 5. So I'm going to put a +1 over here. That gives me a 5k. If I put a -2 in over here, so I guess I'm thinking this combination, that gives me a -4k. Hey, that combines to +1k. This is the correct solution. If it wasn't, or if I had things switched around, it wouldn't give me +1k, and I'd just keep on guessing and checking.